day, everyone. Welcome to Mathematics Alive. Our topic for today is constructing models of Platonic solids. Platonic solids are of this shape. We have a triangular pyramid. We have a cube or a hexahedron. And then we have an octahedron, 8-sided polyhedron. And then we have a 12-sided polyhedron. And we have a 20-sided polyhedrons. We have only 5 Platonic solids. Platonic solids are polyhedrons which have these properties. They have the same size of edges and the same faces on every side. So let's begin. First, we have a triangular pyramid. How to make this? The basic face of this Platonic solid is an equilateral, equiangular triangle. And to make an equilateral, equiangular triangle, we will use our basic construction number 1, copying a line segment. So, to start, we start with a line segment of length of your choice. And I made this length 8 centimeters. So, I will copy this line segment by using the opening of my compass, and I will be swinging an arc here and another arc here. So I will be producing an equilateral triangle, and then from this equilateral triangle, we can reproduce another equilateral triangle by copying a line segment. Just repeat the procedure and you will be able to make the whole net. We call this a net because it's still flat. And the actual net is now this one. The net that we will be producing should have some extra flaps so that you can form the solid end. These flaps are for gluing. So the final product is this. Okay. When you glue this together, we'll have this face, and we will paste this side on this flap, and then this side on this flap. So this is the final product. Next is a 6-sided polyhedron. We usually call a cube, but this is a hexahedron. Okay. To produce a hexahedron, we start with a square. And I chose a 7 centimeter side. And then you can use copying a segment again and extend the sides here. And by copying the segment, you copy one side, and then you reproduce that by just swinging an arc along this line segment. And then you can be able to reproduce equal sides. You are sure that you have equal sides even without using a ruler. And then you can reproduce the rest. And our final output for the net of a hexahedron is this. Again, you produce some flaps so that you can paste the sides that are nearby. So we start with this, and we paste this, then this side will be pasted here, and this side will be pasted here. And now we have a box. And you have the hexahedron, this model. Next is an octahedron. Octa is 8. So we have octa, 8 plus hedron, faces, 8 faces. This is our model. And again, we will use the principle of copying a line segment, and we produce the face, which is an equilateral triangle. And then we start with one equilateral triangle, and then we reproduce that by copying a segment, and then we will be able to produce 8 triangles, and this is the output. And then you produce the flaps here, and we can paste the figure together. And this is your octahedron. Next is icosahedron. We'll be reserving the dodecahedron for last because it's a little bit complicated to form the basic part, which is a pentagon. So we'll start with icosahedron because the basic figure is still an equilateral triangle. So we will just extend the figure of an octahedron and reproduce 20 sides. And this will be our neck. And the final output will be this. Okay. And this is another version, the decorated octa or icosahedron. And then lastly, we have the dodecahedron, a 12-sided polyhedron. Okay. The basic figure is a pentagon. So we construct a pentagon by choosing a convenient radius, and I chose here a radius of 4 cm or 4 centimeters. And using copying an arc here, I copied the arc and divided the circle into 5 equal parts or 5 equal arcs. Each one is measuring 72 degrees because 360 degrees for the circle divided by 5, you have 72 degrees each part. And we start with the arc which measures 72 degrees and just reproduce that arc. Be sure that it is exactly 72 degrees to start with. Then from there, you produce an arc and then another. From this point, we swing another arc here. Then from this point, we swing another arc until we finish with this point. We should reach this point, or else the figure will not be perfect. If you go beyond this starting point, the figure will not be an exact pentagon. But if it reaches exactly that starting point, your pentagon will be perfect. So this is the figure that I made. Okay. Once you have a model of a pentagon, then you can just copy this and reproduce 12 sides. And the final output is this. We have 12 sides, and again, you produce those flaps for gluing. When you paste the sides of this figure, you have to start with just half of this and let it dry after gluing. You will be able to make a bowl-like shape, and then after drying, you paste this other side and again let it dry, and when both are dry, you put them together so that you'll be able to complete the whole figure, a dodecahedron. And for some tips in decoration, you can decorate this. You can put some colors or shapes or pictures on the sides, and then punch a hole here, and you can hang this with a string and make it a decoration for your parties. We have used this in our classrooms during open houses, and the students had a lot of fun in producing these decorations, which are very mathematical. So here we have it, the 5 Platonic solids. Thank you very much for watching, and please don't forget to like, share, and subscribe to this channel by clicking the button below.